Hello everyone, I'm Avinash Mishra from Electronics third year, Punjabi University, Patiala. I'm providing my overview on compensator. When we first heard this word compensator, the first thing is in our mind that is it some kind of exchange of something? Yes, actually it is. So what we are going to do further is what are the compensator, arrangement of compensator and the compensating network. Here comes the compensator. What is the compensator? Before knowing that what is a compensator, know about the basic requirement of a control system, the main performance specification of any control system, like it is stability, accuracy and response speed. किसी भी कंट्रोल सिस्टम के मेन 3 रिक्वायरमेंट्स हैं रिस्पांस स्पीड, एक्यूरेसी एंड स्टेबिलिटी। और जब भी ये 3 रिक्वायरमेंट फुलफिल हो जाते हैं तो उस सिस्टम को हम एक आइडियल सिचुएशन सिस्टम में डाल देते हैं। लाइक से word ideal situation, which is practically we didn't get this type of system. So the method of converting unstable system to a stable, inaccurate to accurate and less response speed to high response speed is to redesign the system. लाइक हमारे पास कोई अनस्टेबल सिस्टम है, उसको स्टेबल में चेंज करना है, अनएक्यूरेट सिस्टम को एक्यूरेट में करना है और लेस रिस्पांस सिस्टम है उसको हाई रिस्पांस स्पीड सिस्टम में चेंज करना है। तो वी शुड हैव टू रीडिजाइन द सिस्टम। एंड हाउ कुड वी रीडिजाइन? By adding some external device, and the technique of the addition is called compensation, and whatever the device we are adding is called compensator. Now compensation of a system can be achieved by following ways, like we have some other system and which is not stable, not accurate and response speed is too bad. Then how could we improve and how could we compensate it? The following ways are there. The first one is steady state error. By reducing the steady state error, so how could we reduce the steady state error? By increasing the forward path gain. And when we increase the forward path gain of any system, any control system, then in the other hand the system become unstable and oscillatory, which is not beneficial. So we come to the another point, which is introducing a compensation network by addition of pole zeros to the transfer function of the system. So as you see in the first chart, when we add 0 to the open loop transfer function, system become stable, speed of the response become fast and the accuracy is got reduced. This is a drawback. And when we add the pole in the open loop transfer function, then system become unstable and the speed of the response becomes slow, but the accuracy increase. Here the upper two are the drawbacks. So how could we compensate a system? जीरो लगा के हम कंपनसेट नहीं कर सकते, बिकॉज जीरो लगाने पे हमारे पास एक्यूरेसी रिड्यूस हो जा रही है। जब हम पोल एडिशन कर रहे हैं तो क्या हो रहा है, हमारे पास स्टेबल सिस्टम अनस्टेबल हो जा रहा है और जो रिस्पॉन्स है वो भी स्लो डाउन हो रहा है। सो हाउ कुड वी कंपनसेट ए सिस्टम? बेसिकली हम क्या करते हैं, हमारे पास जो भी सिस्टम है जो जिसका स्टेबिलिटी कम है, रिस्पॉन्स कम है, एक्यूरेसी कम है, प्रॉपर स्पेसेस पे हम एडिशन ऑफ जीरो करते हैं, एडिशन ऑफ पोल करते हैं टुगेदर, सो दैट एक्यूरेसी भी इंक्रीज हो जाए, स्पीड ऑफ रिस्पॉन्स भी इंक्रीज हो जाए और सिस्टम स्टेबिलिटी भी गेन कर ली। हमारा जो बेसिक मेन रिक्वायरमेंट्स है आर द एक्यूरेसी एंड द स्टेबिलिटी, and accuracy which we got from the addition of pole and the stability which we got from the addition of this. Now our second topic is arrangement of compensators. The first one is series or cascade compensation, second parallel and feedback compensation, load compensation. What is the series or cascade compensation? When a compensating network insert in forward path, this is called series or cascade compensation. In other hand, parallel and feedback compensation, it is a technique. The signal is feedback from some element and the compensator is placed in the resultant inner feedback path. The another one is load compensation. When a series and parallel combination both is combined, then the resultant compensation is called load compensation. Here going through what is a compensating network, the first thing we want to know that what is a compensator. तो पहला चीज हम ये जानेंगे कि compensator क्या है। Compensator actually में it is a physical device which may be electrical network, mechanical or any combination of various type of devices. Basically, the electrical compensating network are generally used, and some of the electrical compensators are phase lead compensator, phase lag compensator, and phase lead lag compensator. Main thing is that how can we classify between the phase lead, phase lag, and phase lead lag compensator? Basically, we have any system, and in input we are providing a sinusoidal signal, but in output we are getting a sinusoidal steady state output but having a phase. Like हमने एक सिस्टम में कोई सा भी साइनोसॉइडल सिग्नल प्रोवाइड करा, बट आउटपुट में भी हमें वही साइनोसॉइडल सिग्नल स्टेडी स्टेट पे मिल रहा है, बट जो फेज है वो फेज डिफरेंस ऑकर्स. सो अगर अगर जो भी फेज डिफरेंस आ रहा है, इफ फेज ऑफ द आउटपुट वोल्टेज लीड द phase of the input, then it is called phase lead network, and if the phase of the output voltage lag the phase of the input, then it is called phase lag network. Here are the two diagrams of figure of lead lag compensator in the left hand side, and on the right hand side lag compensator. Now here we comes to the difference between the phase lead and phase lag compensator. First difference, it increases the phase shift of the system around the gain crossover frequency. Magnitude curve kept relatively unaltered. Increases the gain of a system. Improve the response. Uses more available spectrum. Increase in the bandwidth. Whereas in phase lag, it is used to move gain crossover frequency over a lower frequency. The phase shift curve remain unchanged. Reduce the gain of a system. Improve damping of a system. Larger safety margin and decrease in the bandwidth. Here we come to the advantages of phase lead and advantages of phase lag, and disadvantages are also with them. Like the first advantages is increase in the bandwidth, improve dynamic response, we get desired response. As we know, when we increase the bandwidth, then it's immune to the noise. Like हमने बैंडविड्थ इंक्रीज किया, तो बैंडविड्थ इंक्रीज करने से क्या हो जाएगा? एक ड्रॉबैक बैंडविड्थ इंक्रीज करने से ये है कि जब हम बैंडविड्थ इंक्रीज करते हैं तो जो नॉइज है, नॉइज को एक माइन्यूट प्रायोरिटी मिल जाती है सिस्टम में इंटर करने के लिए, जो हमारा एक डिसएडवांटेजेस है. एंड phase lead compensator may we required a large value of compensator for RC network, like we are using any type of RC network. So whatever the value of R and whatever the value of C, we want it in a large value. And the third disadvantage is required additional amplifier gain. In the other side, phase lag advantages improve the steady state accuracy, suppresses the high frequency noise and applied especially when error constant are specified. Disadvantages reduce speed of response, decrease system bandwidth, slow down transient response, required large value of RC components. Here are some limitations of phase lead compensation, and another side, the limitations of phase lag compensation. The first limitation, it can be used successfully when the value of phi m required too high, and the second thing is that an increase in value of alpha increases the bandwidth and the noise will be higher. Third limitation is it is ineffective in the system having low damping ratio, but it can be effective. It would be effective when larger value of alpha is chosen. On the other hand, the limitation of phase lag compensation, bandwidth of the system reduced due to the lag compensator shift the gain crossover frequency to a lower frequency point. Second, system becomes sensitive relative to parameter variation. The rise and settling time is more because of the reduced bandwidth. Now here the effect of phase lead compensator, frequency response is faster, response peak MP is reduced, phase margin of the system increase, bandwidth increases, velocity constant of the resonant frequency is increased. Another side effect of phase lag compensation, response gets slower due to the undamped frequency is reduced, velocity constant increases for given relative stability, gain crossover frequency decreases, thus decreasing the bandwidth, increases phase margin. Here are the last one, lead lag compensation. Basically, the design of a lead lag compensation by the frequency response approaches is based on the combination of the design technique discussed under the lead and the lag compensation. लीड में जो हमने लीड कंपनसेशन एंड द लैग कंपनसेशन, इन दोनों में जो भी एडवांटेजेस हमने डिस्कस करे थे, लीड लैग कंपनसेशन जब एक साथ आते हैं ना, तो दोनों के एडवांटेजेस मर्ज होके एक फुल एडवांस्ड कंपनसेशन बनता है जिसे हम लीड लैग कंपनसेशन कहते हैं, which having a fast response, good static accuracy, increase the low frequency gain, improve steady state. And the last thing, rate feedback compensation. Root locus help to point out the capability of rate feedback. For achieving the better specific performance, there must be larger number of variable inserted into the system and the design become more complex. There are two methods to design a system by a rate feedbacks are single parameter loci, multi-parameter loci. Here are some link of references from where I got that information and the images.